So this is page 548. We're going to try number 11 here. We're going to figure out the area of each regular polygon, rounded to the nearest tenth. So for number 11, we've got a regular triangle here, an equilateral triangle. One of the things we're going to need is the formula, which of course is 1/2 apothem times perimeter. The perimeter is not going to be a problem since we have the side length of 8. So we know the area is going to be 1/2 apothem times 8 times 3 on a three-sided figure. So the perimeter is 24. The problem is going to be the apothem. We're going to need to have this side length right there in red. What we're going to have to start with is starting from dead center. Give me some of these angles here from dead center. So if you take 360 degrees divided by 3, this is 120 degrees. 120 degrees, and then that red apothem is going to split the 120 into 60 and 60. And of course this makes a right angle there. Now we're going to try to figure out that red apothem here. I'm going to kind of just highlight one of the triangles here. This is A for the apothem. This would be the 60 degrees. This is a 30 degrees. This right here is now 4 and 4 because that of course is half of 8. And so first you've got to get the angles, 60 to 30. We're going to try to figure out the apothem. We're going to just stand at either the 30 or the 60. I'll stand at the 30. I'm going to say tangent of 30 degrees is equal to opposite apothem over adjacent, which is 4. Once I know what the apothem is, and of course you're going to use a calculator, just plug it in here. We already know that the perimeter is 8 times 3, 24, and so you would just crunch it all together and get the area using trig. Okay, we're going to try number 15 here. We're going to try to figure out the area of the regular polygon, and we are going to leave it in simplest radical form, so like radical 3, radical 2. Number 15 here, we got a hexagon, a six-sided figure. We know that the formula is area is 1/2 apothem times perimeter. They actually give us the apothem. It is 8 radical 3. What we need to do is figure out the perimeter. Now, like the previous problems, you need to break down and figure out the angles in the middle here. So I'm going to kind of draw the 6 triangles. And so 360 divided by 6 is 60 degrees. So each one of these is 60 degrees. And of course, these degrees will help figure out the side lengths here. This will be 30 degrees. So what I'm going to do here is enlarge this one triangle here, focusing on this one triangle. It is 30 degrees, 90 degrees, 60 degrees. We've got a 30, 60, 90. We have this apothem of 8 radical 3. So what we need to figure out is this portion right here. I'll call that letter Y, from here to here. And then if I double it, I will eventually be able to get the perimeter. That is also a Y. But how do I solve for that Y? Well, you got to know your 30, 60, 90 triangles. I kind of drew one right over here as a reminder. If it is opposite the 60 degrees is 8 radical 3, then opposite the 30 would just be 8. So that means this portion right here is simply 8. Let me get that on the screen. And the other part right next to it is also 8. And of course that means 8 plus 8 is 16. So each one of these side lengths is 16. And from there you should be able to figure out the perimeter. And of course, once you have the perimeter, you have the area by multiplying 1/2 apothem times perimeter. Okay, we're going to figure out number 31 here. Find the area of the regular polygon here. This is obviously a 4-sided figure. It's a square. Like all of them, we want angle measurements from the center. They actually give us this radius of 8 here, 8 centimeters. We are going to need to first figure out these angle measurements. So it's 360 divided by 4, which is 90 degrees. So each one of these is 90 degrees, and obviously it looks like it. And then when I draw the apothem, it splits the 90 degrees in half. So I'm going to enlarge this triangle right here. So we have a triangle here. We are given this 8. This is actually half of 90, 45. This is a 45, 45, 90 degree triangle. This is A for the apothem. This is X, one of the side lengths here. which will help figure out the perimeter. But really, a and x are the same answer here. You could just simply stand at either 45 and just go sine of 45 is equal to opposite x over 8. And so if I do this in the calculator real quick, you will get x, which is also the apothem, 5.65, so forth. So this is also the apothem because it's a isosceles triangle. So both the apothem and x is 5.65. Now I'm going to double this x here to get a side length. So if I multiply that by 2, I will get 11.31. And that's the length of a side because 2 of them down here make a complete side. So now I can figure out the perimeter. I got the apothem, 1/2 apothem, which is 5.65, and then the perimeter, which is each side is 11.31, and I'll multiply it by a 4-sided figure. And whatever this is calculates out to be. There's also another way to solve this problem. Because it's a square, you can just simply go base times height. And if I know one side is 11.3 and it's a square, the other side is also 11.31. So this is another way. You should get approximately the same answer there. It might be slightly off because of the decimal, and I rounded.